I would like to talk about membrane deployment DDC system by convex tape. At the beginning, I'd like to show you the outline of my presentation. First of all, requirement of our DDC device. Next, basic design, detail design. Finally, concluding remarks. First of all, requirement of DDC device. There is a requirement for the following 10 contents in DDC device. This detailed explanation will later. Next, I will explain basic design of DDC device in this section. This movie shows simple model of DDC device deployment behavior. Simple model of DDC device is composed of mainly convex tape, membrane, and hub. DDC device consisting of 4 convex tape and 2 triangular thin membrane can re-enter over 3U size than satellite with 4 kg weight on low Earth orbit into the atmosphere by increasing the air resistance. Also, membrane deployment DDC system by convex tape is light, compact, reasonable because it has less component parts. Next, principle of deployment mechanism. The convex tape is capable of self-extension when it is rolled up. The proposed device employs these characteristics of the convex tape for the deployment of the membrane. This figure and movie shows the principle of the deployment. The convex tape are wrapped around the cylindrical hub that can rotate free around the center shaft. When it releases the hole, each tape starts to extend around the guide roller that is located so that the tape extends towards the desired direction. Next, experiment under microgravity environment. We fabricated a prototype of the device and conduct deployment experiment under microgravity environment using an airplane in February 2016 to verify the mechanical and electric design. This figure shows the prototype in stored state and in deployed state in the airplane. This movie shows a result of the deployment in microgravity. Choose the principle of deployment has been already verified in microgravity. We deployed the device satisfying 10 requirements based on basic design. I will talk about detailed design of the device in this section. This illustration is proposed device, the device in stored state. The envelope of the device is width 90 mm, depth 76 mm, height 46 mm, and total mass of the device is 0.246 kg, so that it can be attached on the top of a CubeSat. Next topic. Describe the convex tape using in the device. The commercial tape measure is available for convex tape of the proposed device. The shape of the convex tape is shown in this video. And the material parameter of the tape is listed in this table. Next, deployment mechanism of the device. This movie shows proposed device deployment behavior. Please refer to the movie. Slide view. From this movie, it was confirmed for device self-deploy. The sequence of the deployment is illustrated in this video. The detail is as follows. The convex tape wrapped around the hub, the membrane are folding in case. The deployment mechanism including membrane and tapes are pushed by two stopper under the solar panel. Both stopper are held down by dynamo wire. The proposed device has conventional port release mechanism using wire and heat cut system. When the electric current flows in the nickel wire, the dynamo wire are cut by the heat of the nickel wire. The stopper opened by assist of the spring hinge so that the deployment mechanism jump up like a jack in the box while the spring in the case. Then turn on the electromagnetic brake so convex tape and membrane begins to extend. Electromagnetic brake is attached under the hub as lower video. From here, I will explain the 10 requirements. First of all, effectiveness. When the proposed device is attached on the top surface of a 3U CubeSat at this video, the orbit lifetime of the satellite is about 3.68 years according to the orbit calculation software does. Next, mass and envelope at launch. The total mass, the proposed device is 0.246 kg and envelope with 90 mm, depth 76 mm, height 46 mm as shown in this figure. The device can be attached on surface of a CubeSat. Choose the proposed device fit into CubeSat. Next, cost. The device can be made of parts product at DIY store through internet shopping. This table shows a list of the parts used for the proposed device. All parts is reasonable, so the price is only $800 including margin. Next, mechanical design. We observe the convex tape begin to separation from the loading hub under the certain condition, which result in the jump of the tape in the device and the failure of the deployment. This movie is separation. The separation occurs if the angular velocity of the hub exceeds a certain value. Therefore, we introduce the rotary damper that gives the constant negative torque to the angular velocity to the hub in order to reduce the angular velocity of the hub. This figure shows an example of the time history of the hub of the prototype. In case of no rotary damper, the angular velocity reached more than 7,000 degrees per second, and the convex tape separated from the hub, so that the deployment failed. It was found the upper limit is 6,530 degrees per second. On the other hand, the angular velocity of the hub with the rotary damper is circulate and the deployment was successful. This figure shows the time history of the angular velocity of the floating hub in the microgravity experiment. The convergence value of the angular velocity is sum as in one gravity environment, and the deploy was successful. As mentioned above, the possibility of mechanical design was verified through the deployment experiment in microgravity environment. However, the deployed membrane shape of each experiment is different from each other. The experiment was conducted for three types of folding: Miura folding, Eros folding, stripe folding. As seen in the lower figure, the area of deployed membrane is largest in case of stripe folding in microgravity environment. The same result was obtained in the experiment under one gravity environment. From the result, the stiffness of the whole line gives serious effect on the deployment. Choose, we adapted the stripe coding for the proposed orbit device. Next, electrical design. The proposed device is designed so that it can be activated even if the satellite main system is failed. This figure shows the system block diagram of the proposed system. The detail of the sequence of the activation is follows. The latching relay connects the solar cell and the CD cell switch and the transistor switch are normal open. When the satellite is deployed into space, the CD cell switch is exposed to the strong sunlight in space, and the CD cell switch closes. Then the self-folding switch is closed. Consequently, the electric current flows into the MPU and MPU is turned on, and the MPU starts the count. Furthermore, the MPU switches the connect of latching relay so that the solar cell is connected to the regulator that is connected to the battery charge controller IC. Choose the electric power generated by the solar cell is supplied to the MPU. In the result, the battery is always almost fully charged and the MPU is always turned on. Also, when the MPU receives the signal or standby from the satellite, the MPU resets the time count. Right? The MPU resets time count. If the MPU receives no signal from the satellite for certain duration, it closes the transistor switch so that the hold mechanism is activated, the membrane structure deploys. When the MPU receives the signal for the activation from the satellite, it closes the transistor switch so that the hold release mechanism is activated and the membrane structure deploys. Next, impact on satellite. The proposed device is 5 meets this requirement. The device can be put on the top surface of a CubeSat. The height of the device is 46 mm. The weight is only 0.276 kg. The device does not require the power from the satellite. Only for MCD board and 2 signals is required to attach the device on the satellite. Next, the device is 5 meets this requirement. The deployment method has been already proposed in space. We have already clarified the cooler mode. The hold release mechanism using the heat cut system has been already proposed in space by various CubeSats. The 2 signals are sent from satellite by different lines to avoid the malfunction. Device works without the power supply from the satellite and even without the signal from the satellite. Next, safety. The device is 3 meets this requirement. The proposed device does not have any propulsion system so that gas liquid will exhaust. The system of the device is turned off when it's launched. The hold release mechanism using the heat cut system has to inhibit to avoid the unexhibited deployment. Next, maintain and stability. The device is 3 meets this requirement. The terminal pin for the battery charge is exposed at the side of the device. The hold pattern is quite simple. The wrapping of the convex tape around the hub in concrete. Next, usability and deliveries. The proposed device meets each requirement. The device does not require the power from the satellite. both hold on to signal line in requirement to attach the device on satellite. The proposed device function even if the satellite system is failed or the electrical interface between the proposed device and the satellite has trouble. The proposed device does not generate any object. Finally, concluding remarks. The prototype of device was already verified and explained, including the deployment experiment under microgravity environment. The reliability, safety, and the application of the debris is considered in the design of the device as well as the mass and the envelope. From the above, we are ready for deployment the flight of the model. I'd like to close my presentation. Thank you.
Thank you, Mr. Tada, for your presentations. It's a time now for questions.
What is the effective area of your fan, of your deployed system? I didn't see it in your slides. The area. Once it's opened, your sail, how big is it? What is the area in square meters?
One membrane is 0.3 meter square.
For one. So it's 0.6. Or do you have 4?
0.3 square meter.
For one membrane.
One membrane.
And 2 will give you 0.6. So the 3.68 years orbit lifetime, is that for the 2 membranes? 0.6 square meters.
Could you show me the circuit diagrams? Yes, this one. So everything's MPU, battery, solar cells are independent from satellite. It has its own MPU, batteries, and solar cell. They are all different from the satellite bus.
Satellite bus.
That solar cells, is that independent? Okay, also battery.
Battery independent.
Okay, what battery do you plan to use?
The proposed device is designed so that it can be activated even if the satellite main system is.
The battery type, is that
battery type lithium battery.
do you need a big battery for that one? I didn't see the batteries in a picture, so
I think so. I don't think so. Battery scale. Yeah, not yet.
so the battery is inside that devices.
No. Board attached the deobit depth.
The battery is inside the deobit device. Yes, it's a battery included here.
Battery and board is not attached to the device. The board is scheduled to put on the bottom on the deobit device.
Okay, the bottom. Okay, so it's not inside this box. Okay. Okay. And what if MPU malfunctions? If MPU malfunctions due to radiations or something, what happens? Never deployed. If the MPU if the MPU is damaged or malfunctions because of radiations or some things, this never deploy? Okay.
Any other question?
You said the total mass is 246 grams, 246 grams, 246 gram, the weight of the deployment system, the orbiting system. The total weight, 246 grams. Does that include the mass of the battery and the solar cell and the electronics? So without all the electronics and battery and solar cell. Your circuit diagram, in your circuit diagram you've got lots of components. Those components also weigh something. It's not zero weight. The battery cannot be 0 grams. So did you include that in the 246 or not? It's not included.
Most products and for no.
Well, I have two questions, and one is what will be the rough estimate of your total system mass, including battery and circuit board? Will it be around 500 grams or more? What is the rough estimate of the total system weight, including battery? Battery. I don't need the precise number, but rough estimate is okay.
I think 400 kilograms.
Okay, thank you. And the second question is about the microgravity experiment. Could you show me the movie? Microgravity experiment. Yeah. It seems that the deployment sequence is not so smooth. So, could you explain why it is not so smooth?
Principle of the orbit system is simple. Yellow point is shield. Yellow point is shield and many points.
So I understand that you prepared many yellow seal to measure the deployment mechanism, and the seal is so sticky to prevent the deployment not so smooth. Thank you.
Can you comment on the volume and mass increase if you reduce the deployment time by half, say?
The way the device is weight up, and the orbital lifetime is reduced. And the orbit system is weight up, and lifetime is reduced. I not calculate.
Okay, any other question? Okay. Please. Last question.
What was the cost of your device? And it's using the space qualified materials and all the coatings and manufacturing of the parts? It includes everything with also electronics?
Not to include parts.
No manpower or electronics. Does it include the electronics or also not the manpower to manufacture? So man-hours to make it, to manufacture it. This is just the components.
Not included. Okay. Okay, I think the time is running out. Let's thank our speaker again.